Hello everyone, today we are solving another example on PDA. So what is the question is design the PDA for the language A raised to n, B raised to n and C raised to m. M n greater than equals to 1. So in the previous videos we have seen an example of A raised to m, B raised to n and C raised to m plus n. Okay, now see what is the difference here. In the previous videos this question there was a connection, means if there are m times a n times b, means a raised to m means m can be any value, n can be any value. So c, how many times c will come, that depends on a and b. But in this you can see a raised to n and b raised to n, means a raised to n, a and b are have a relation, means there must be 3 times a then 3 times b, 4 times a 4 times b, but there can be any number of times c because it is m not n. So means there can be 4 times a, 4 times b, 1 times c, no issue, it will work. Okay, now see what logic we can implement here. Since a and b are related, so I can do a push and pop. Since c is not related, so what I will do, I will bypass every c because there is no relation with a and b. No, in the previous question, in the previous videos there was a relation, means if a raised to m, b raised to n, then m plus m. But since here there is no relation of c with a and b, means how many times c must be there in the string for the string to be accepted, that's why we will bypass the c. So I'm start solving this. First is we have to write the theory. In this we have to write the definition plus mathematical equation. Okay, now step 2. Step 2 is logic. For each a, push 1x. For each b, I will pop 1x. Pop 1x. Okay, since a raised to n and b raised to n, n is the power. Since c's power is m, that have no relation with it, what I will do, I will say bypass every c. Okay, so now see, q is a finite set of states. I will see z naught as z. Input alphabet is a b c. What can the stack elements? Stack elements will be x and the initial this stack symbol z. And yes, our final we have to write. Okay, now see, q0 will be the initial, so I'm writing a q0. So what implementation we can see? Implementation. Now see, if I receive q0 a and the stack top is z, what I will say, yes, stay in the same state, push and x. Okay, if is a q0 and the element is a but the stack top is x, so what I will do, yes, it is a, no issue, I will push only. Okay, now see, if q0, if a's are completed, means in the string a's are traversed, now b comes and the stack top will be x only because previously a's, because of a the x were pushed, that's why x. So what I will say, change the state and pop. As I told you in the previous video, this also indicates the pop, or you can use here this q1 xz, no issue. Okay, in some books it has given like this, or you can use this. Now see, in the q1 it comes and there can be many b's, so what I will do, and the stack top can be x only. What I will say again, stay in the same state and pop. So you can write this q1 x. No, what I will say, xz. Okay, you can show xz also, no issue, or you can use this. When q0 receives b, say I am saying go to q1 and pop. And q, when it is in q1 but b is, then stack top is x, so yes, you can pop, no issue. Now see, due to both these steps our b traversing is completed. Now see, if q1 receives c, now remember, for n times a there will be n times b, so for n times a there will be that times x, and that time x will also will pop. So what we are stacked of z now. Okay, if q1 c z, so what I will say, I have to keep a track. So what I will do, I will say go to q2 and keep the stack top as it is, no issue. I don't want to pop or push anything, I will bypass. Now again, it will be in the q2c and stack top will be z only. What I will say, bypass C only, no need to push, no need to pop, the stack top will be same as this. Okay, now it will, this step will bypass the c's and this will also bypass, no issue. Now see, when q2 and the string is over, none and z is the stack top, what I will say, go to final state and keep the stack top as it is, no issue. Okay, now see how many states we have, q0, q1, q2 and qf. So I will write this here, q0, q1, q2, qf, and final state is qf. I am explaining this once again. When the first element will come, the stack top will be z only. So if q0 receives a and stack top is z, push 1x. Now see, if we have pushed 1x, then the second a will be stack top. When second a will commit stack, it will see the stack top is x. So for this q0ax, it will q0xx, q0bx. Now see, I am taking an example here to, it will help you to see z. I am taking a b b b. Okay, now see, yes, I will put c also at last, c c. I am taking two c's. Okay, now see, first a, stack top is z, push 1x in a q0 only, in a q0 state. Again this second a will come, now stack top is x, so this transition will work. I will say put 1x again. Now this a again is a q0 only but stack top is x, so this will only work. Again push 1x. Now see, it is in a state q0, q0bx. Now see, q0bx, yes, stack top is x and it is b and it's set q0. What I will do, go to q1 and pop 1x. Okay, now see, I'm going to second b, now it is q1, so q1b and stack top is x, so q1bx. So what I will say, stay in a q1 and pop. I'm popping. Again for this third b, I am saying yes, it is a q1 b and stop, stack top is x, so I will say this only will work, pop it. Now see, c comes, it is in q1 and stack top is now z, so q1 c z, q1 c z. What I will say, yes, go to q2 now. Okay, q2 and this is now second c and stack top is z, so I will say no need to push and pop, bypass it, so it will be the same state and this c will also get traverse, and there can be many c's also, this, so you will all will get bypassed. In this way you can check your implementation. Okay, now our step 4 is the transition diagram. Okay, transition diagram. Now see, there are three states, q0, q1, q2, qf. There will be transitions. I am drawing this. Okay, now see, q0 receives az, xz. What I will show, q0 AZ XZ. Q0 receives AX XX. So I'm writing here Q0 receives AX XX. Now see. Q0 receives BX, go to Q1 and pop. BX, go to Q1 and pop. Now see, this is implemented in the diagram. Q1 BX, so what I will say, Q1 in the Q1 BX, so stay in the Q1 and pop. So BX, so what I will say, yeah, pop again. Now see, Q1 CX, so go to Q2 and don't need to pop or push anything. So I will say Q1 CX, no need to push or pop, go to only Q2. So it is only changing the state. Okay. Now see, Q2 CX, stay in the Q2 and Z, means no need to push pop. So C Z, no need to push and pop, keep the stack as it is. Okay. Now see, Q2 null string Z. If Q2 receives null string, to go to QF, so null string, go to final state. Okay. Now see, 1 2 3 4 5 6 7. 1 2 3 4 5 6 7. There are 7 transitions, so that is implemented in the transition diagram. Based on this, I will solve an example. Step 5 example. What is the example? I am taking Q0, I am taking 2A, 2B and 2C, 3C, no issue. I am taking 3C. Okay. Now see, for here n value is 2 and m value is 3. Here n is 2, m is 3. Okay. Q0 receives A, say in a Q0 only, A, B, B, C, 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 X, Z. Q0 again it will receive A, it will stay in a Q0, B, B, C, 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 again X and Z. Now see, Q0 receives B, go to Q1, B, C, 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 pop 1X, it will be XZ. Q1 receives B, Q1, C, 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 again X will be popped and stacked up will be Z. Now see, Q1 receives C, go to Q2, C, C, and it will bypass 1C. Again Q2 will receive C, so it will go to Q2, C, bypass that C, Q2, this will receive C, so bypass, and there will be null string and there will be Z. Okay. Now see, Q2, this Z, it will go to final state QF and Z. It is a final state, what I will say, accept it. Now you can solve another example of rejection. I am giving you to solve an example of rejection. You take a string on of your own and you can solve. So I am giving one string C, you can solve. A 3 times B 1 times C, no issue, and Z. You solve it and check it. It will get rejected because A is 2 times, B is 3 times. Means there is one less A or one more B. That's why it will get rejected. In this way, we can solve a sum on PDA. Thank you.